Hey everyone, welcome back. We are going to look at a problem that many of you requested. This is taken from the Harvard MIT Mathematics Competition for high school students. And this particular problem goes like so. F, or f of x, I'm going to leave it as f, is sine to the sixth power of x over 4 plus cosine to the sixth power, also of x over 4. And with that function, I want to find the 2008th derivative and evaluate it at x equals 0. So, someone tell me, if I started taking the derivative of this thing, what rules would I have to use?
I have to use the power rule.
Power rule?
Chain rule.
Chain rule. That's just for the first derivative, right?
Yeah.
However, the second derivative, that's even more.
The product rule, I'm assuming.
Product rule, chain rule, it just gets quickly a mess. So this all in all is a quite wild problem. And this wild problem requires a different attire, I fear. All right, y'all, so now this is Cowboy Barkley in the house, ready to tackle this wild trigonometric fella here.
How long have you had that wild cowboy hat, sir?
What was that, Jordan?
How long have you had that wild cowboy hat, sir?
As a matter of fact, sir, I have had this cowboy hat since the day I was born. When I was coming into the world, the doctor took one look at me and just said, "Wow, that's a wild one." And he just put a hat on me, and I've had this ever since.
And it fit your baby head just as
Yes.
nice.
My head is just the same as it was then.
Cool.
My poor mother. Anyway, now, to tackle this, we actually just have to fall back on a few friendly fellows here. A cubed plus b cubed. I can factor that, someone help me out here, into a plus b times what?
Jeez.
What's this first one?
A squared.
A squared. What's the last one?
B squared.
Does anyone remember what sign I got to put in the middle there?
2a plus 2ab
Not,
squared.
no.
Minus.
Minus. And it's actually just a plain AB.
Okay. Okay.
And a plus. So just a nice friendly fellow from Algebra 1. Someone tell me what this equals. What about sine of 2 theta?
2 sine theta cos theta.
Yes, 2 sine cos. Does anyone know how I can derive that formula, by the way? What's sine of a plus b?
Sine a cos b plus sine b cos a.
Exactly. And if a and b happen to be the same thing, let's just call it theta, we get 2 sine
The
cos.
same thing. Okay.
Yes.
Nice.
What about cos of 2 theta? What does that familiar friend equal? Yeah, it's cosine squared minus,
1.
not 1, but sine squared. And last but not least, if I square sine of anything and I add that to cosine squared of the same thing,
That's equal
That's
to
1.
1.
always equal to 1. That's your Pythagorean identity in trig. So we're going to hold those in remembrance, and I'm going to apply them here right off the bat. I'm going to apply the top one. With this in place, I can write f as sine squared x over 4 plus cosine squared x over 4, yes?
Yeah?
Because if I cube this, I get that. If I cube this, I get that, yes?
Yes.
You following, Victoria?
I think so.
Cool. All right, and that's all going to be multiplied by,
sine of 4 to the x over 4
yeah, sine of the fourth, x over 4,
minus sine squared x over 4 times cosine x over squared x over 4.
yeah, which I can write, by the way, as sine x over 4, cos x over 4,
All squared.
all squared, plus,
Cosine 4x over 4.
yes, cos 4x over 4. Now then, this first parenthetical, what jumps out at you about it?
That's 1.
That's
right?
1.
Yes, no matter how complicated this thing here is, it's always going to be 1 if they're the same thing. So boom, now we're automatically back down to dealing with something in the power of 4. So a massive decrease in complication. Now look at this here. I see sine of the same thing times cosine of the same thing. What does that remind you of? Or what jumps out at you from this side when you look at that?
Sine 2 theta.
I need a sine theta times cosine theta.
Sine 2 theta by 2.
Yeah, I don't want that 2, so I gotta divide both sides by 2. So 1/2 sine 2 theta equals sine theta cos theta.
Mm-hmm.
Wow.
So here I have 1/2 times sine of what?
X over 4
Times.
cos of x
Sine.
over 4.
So here,
No.
here's the theta, here's the theta. I want to rewrite this in terms
Oh,
of
x, so is it x over 8?
not x over 8, it's going to be 2 times whatever that
X
angle
Oh,
is.
so
over
x over
4.
2.
X over 4 times 2, which is
X over 2.
2.
X over 2, yes. And I am squaring that entire thing. So let me rewrite this now. So here's my f. I can more simply write this as
1
sine of the fourth of x over 4.
half sine x over 2 squared.
I'm going to put this cosine fourth right after it. Just because it patterns up better. Minus this entire guy squared. 1/2 squared is
1/4
1/4.
sine of x over 2. Sine squared x over 2.
Yes, sine squared x over 2.
Okay.
And let's just straight off take the derivative. So that first term here, someone help me out. What is the derivative of sine to the fourth of x over 4?
4 times sine of x, sine 3x over 4 times cosine 4 of x over 4.
Not 4, but just x over 4.
Okay.
Chain rule. Got a chain rule again for the x over 4 times
Times 1 over 4.
1 over 4. And same deal for this guy.
Okay. So
Uh,
that's
So plus.
plus 4 times cosine 3x over 4 minus, or times negative sine of x over 4 times 1 over 4.
Times 1 over 4, yes.
Yes.
Before I go on to the very last term, what do you notice about these 4s?
They
There and
all-
there.
That cancels out.
Yeah. Die. Die. And just to keep things a little simple, I see a plus and a minus. I can make this guy
A minus.
a minus, precisely. And with that, I'm going to leave that as it is. Now, someone help me with the derivative of that last guy.
Okay. That would be minus.
So 1/4 times.
times 2 cosine.
First, you got to do power rule.
Oh yeah, 2 sine of x over 2.
Sine of x over 2. What's the derivative of sine of x over 2?
Cosine x over 2.
Times.
1 over 2.
1 over 2. Yes. Ooh.
And those 2's can cancel out, just like the 4.
Yes, those 2's do cancel out just like the 4's. Now I can do something more with this before I go on. What is sine of x over 2 times cosine of x over 2? So just doing something we did a second ago.
Theta.
Not sine of 2 theta.
Sine of x.
Sine of x would times something. So remember, if we just have sine and cos,
Oh yeah.
if we don't have the 2, we got to use this adjusted identity.
Sine of x times half.
1/2 times sine of x. And so I have 1/4 times 1/2 times sine. And all in all, I have this new derivative. F prime equals this minus 1/8 sine. Now, someone look at these first two terms. Sine cubed cos and cos cubed sine. Does anything leap out to you when you see those two terms? What do you think to do from algebra?
Oh, that can look like cos 2 times. That rings out cos 2 theta for me.
It does. You get cos 2 theta after you factor out the things that are common to this and this,
Okay.
which is a sine, one sine,
one sine, and one cosine.
one sine, and one cos, precisely.
And that's all times sine squared of x over 4 minus cosine squared of x over 4.
Yes. Now, this isn't precisely in the form cos squared minus sine squared. But I can get something that looks like cos squared minus sine squared if I just say,
That could be cos of x over 2.
Well, all I gotta do, I just gotta take this,
Yeah.
factor out a negative.
Oh yeah, negative cosine of x 2 times x over 2.
Right. Agree?
That's cos 2 theta.
That is cos 2 theta. What is my theta?
X over 4.
X over 4. Well, times 2, yes.
Yes.
What's
So cos x over 2.
Cos x over 2.
And it's negative, right?
Yeah, after I put the negative, it's going to be negative. What about this guy here?
That will be sine of x over 2
Times.
times.
I don't have 2 sine cos, I just have sine cos.
Oh, divided by 2.
Yes, exactly that. Adjusted trigonometric identity. So 1/2 sine x over 2 cos of x over 2. So let's see what I have all in all here. Here I have 1/2 times sine times negative cos, or negative 1/2 sine x over 2.
Oh, are you missing anything from the previous step?
Previous
Like
step.
the 1/2 sine of x on the right side?
And I'm going to write that down now.
Okay.
So this right here is what these first two terms simplified into.
Okay.
Now, tag on the last term. 1/4 times 1/2 times sine.
So negative 1/8 sine of x.
Negative 1/8 sine of x. See anything else I can do? Sine x over 2 times cos x over 2 is 1/2.
1/2 sine of x.
1/2 sine of x, exactly. So my final form of this final boss is negative 1/4 sine of x minus 1/8 sine of x. Actually, not the final form, but the penultimate form. There's one more thing I can do to simplify this. What is negative 1/4 minus 1/8?
Negative 3/8
Yes.
sine of x.
Look at that. This was our derivative at first. And when you see that, you don't think that would simplify to anything nice, do you? But it turns out to be something quite nice. This is our f prime. Anyone have any questions about that?
And now we're just supposed to take the derivative of that.
2008
2007
times. 2011 more.
Yeah.
So, let us travel around the world here. Boom. First derivative was like so. What's the second derivative?
That will be 3/8 cosine of x, or negative 3/8 times. Oh yeah, negative 3/8 cos of x.
Yes. Victoria, help me out. What about the third derivative?
Negative 3/8 sine x.
Positive 3/8 sine x.
Yeah. Derivative of cos is negative sine. The negatives offset each other. Fourth derivative,
Cos 3/8 times cos of x.
3/8 times cos. And what do you notice about the fifth derivative?
It's the same as the first derivative.
It's the same as the first.
So now that's 5.
We are back where we started,
Nice.
so the pattern just repeats. I'll write out one more full cycle for good measure here.
Okay. And so by looking at this, you can see that any multiple of 4 will be 3/8 times cos of x. So
Exactly. Is 2008, is it not a multiple of 4? Is it a multiple of 4?
it is a multiple of 4.
Right. Something's a multiple of 4 if the last two digits, the number form of the
But
last two
divisible
digits,
by 4.
is divisible by 4, exactly. So,
It'd be nice to write it down 2008 times.
2008 dashes.
yeah, I mean, look, for some people that would be therapeutic. For me personally, it's not. So we're gonna skip that part. 2008 is 3/8 cos. And so final answer, someone help me out here.
3/8 times 1, which is 3/8.
Precisely.
Nice.
A very, very nice problem. And notice just what it fell back on all our familiar friends from algebra and trig.
Mm-hmm.
It only required the basics of calculus, but it requires you to remember a lot of the details of trig in Algebra 1 and Algebra 2. So,
Yeah, no, I wouldn't say a lot of detail. These are big theorems in Algebra 1 and Algebra 2.
That's right.
And trig. These aren't obscure little things. So, those things in concert with product rule, chain rule, give you your answer. Any questions?
Good job.
No, that's a wild problem.
It is wild. It's
Wild,
wilder than me, even on the day I was born.
wild made simple.
Okay.